Okay, so when you hear the phrase titans of modern physics, who comes to mind? Einstein, right? Schrödinger, Heisenberg, those are the big names. But what if I told you the person who gave all their incredible work its true meaning is a name you might not even know? Well, today we're diving into the story of Max Born, the quiet genius who was the real architect of our quantum world.
And to really get what he did, we have to start with this really deeply unsettling question. For centuries, science was all about certainty. It was this beautiful clockwork universe where every single effect had a specific, knowable cause. But this question, what if it's all just a game of cosmic dice? That was the puzzle that Max Born dared to answer.
To appreciate his answer, we got to go back in time to the early 20th century. Physics was in a state of just brilliant chaos. I mean, the old rules were breaking down left and right, and this strange new reality was starting to take shape from what everyone was calling the quantum puzzle.
You have to imagine what a total mind-bender this was for physicists. For hundreds of years, their world was neat, orderly, predictable. You push something, it moves. Simple. Suddenly, they're slammed with the quantum world, where things are just bizarre, uncertain. Particles are acting like waves. They're in multiple places at once. It was absolutely thrilling, for sure, but also deeply, deeply confusing. And think about this for a second. Guys like Erwin Schrödinger and Werner Heisenberg had come up with these unbelievable new equations that described this quantum weirdness perfectly. The math worked flawlessly, but they couldn't agree on what it was actually describing in the real world. It was like having the most amazing, detailed recipe ever written, but having absolutely no idea what you were supposed to be cooking.
And this is where our architect finally steps onto the stage. The person who would take these incredible, mysterious blueprints and show everyone the actual structure of our quantum reality was the German physicist and mathematician Max Born.
Now, Born wasn't just some other physicist. He was a force of nature. He was educated at Göttingen, which at the time was the undisputed center of the mathematical universe. His mind was just perfectly built for this new super abstract physics. And eventually, he went back to run the institute, turning it into a magnet for the brightest minds on the planet. He was right at the heart of the whole revolution. And it was right here, in 1926, that Born had an insight that didn't just add to quantum mechanics, it defined it. He sparked what was, and I'm not exaggerating, a probability revolution.
The whole puzzle, the whole shebang, it all came down to this one question. Schrödinger's famous equation describes something called a wave function. That's the Greek letter psi you see there. But what was it? Was it a literal wave? Was an electron like a physical smear of energy spread out in space? Nobody knew, and the entire meaning of this new physics depended on the answer.
Then, in a stroke of absolute genius, Born proposed something truly radical. He said, look, that wave function, it's not a physical wave at all. It's a wave of probability. The math, he explained, doesn't tell you where an electron is. It only tells you the odds, the probability of where you're going to find it if you go looking for it. This beautifully simple idea is now known as the Born rule.
And just like that, in that one moment, the universe stopped being a predictable machine. Because of the Born rule, physics wasn't about predicting one definite outcome anymore. It became about calculating the chances of all possible outcomes. The very foundation of reality, Born was telling us, wasn't certainty, it was probability.
As you can imagine, an idea this huge did not go over well with everybody. In fact, it kicked off one of the most famous and profound debates in the entire history of science, and it pitted Born against his own good friend and colleague, Albert Einstein.
Einstein's objection is just legendary. He would not accept that the universe was fundamentally random at its core. He truly believed this randomness was just a sign that our theory was incomplete, that there were some hidden rules we just hadn't found yet. For him, a universe governed by chance was just unthinkable. But Born, he held his ground. He argued that Einstein was missing the whole point. This uncertainty, he said, wasn't a bug in the theory that we needed to fix. No, it was a fundamental feature of reality itself. Nature, at its tiniest, most fundamental level, simply doesn't play with certainties. It plays with possibilities and probabilities. Now, while the Born rule was his absolute crowning achievement, his impact didn't stop there. Not even close. His true legacy is measured not just in his own ideas, but in the generations of scientific giants he helped create. But here's the part of the story that really cements his unsung hero status. His own recognition took forever. He published this world-changing idea in 1926, but he wasn't awarded the Nobel Prize for it until 1954.
That's almost 3 decades later, long after many of his own students got their prizes, and after he was tragically forced to flee his home in Nazi Germany. I mean, the sheer gravity of his influence is just staggering. Look at this list. It's not just a list of students. It's a who's who of 20th century science. We're talking multiple Nobel laureates, the father of the atomic bomb, pioneers in nuclear physics. Born didn't just have students. He mentored a generation of absolute titans.
You know, in the end, I think his contemporary and fellow quantum giant Niels Bohr really summed it up best. Max Born's contribution, it wasn't just another piece of the puzzle. He gave science an entirely new framework, a whole new language, the language of probability, to understand the very nature of existence.
So we're left right back where we started, with the incredibly profound implication of his work. His idea has been proven right again and again and again for nearly a century now. It's the foundation of our smartphones, of medical imaging, of so much of our modern world. And yet, it leaves us with this final, fascinating thought. If the architect of our quantum world was right, and reality really is just a game of chance, what can we ever truly be certain of?